Okay, for question number 8, this is your typical airplane, airspeed, ground speed, that kind of question. The reason I said it's typical because the question provides you with the airspeed and also the wind with their speed and directions respectively. And all you are asked to do is to find out the ground speed and the course. Now, let me explain one more time what's ground speed. Okay, now if there's no wind, then the speed of the plane, which is the airspeed, is the ground speed. Okay, if there's no wind, but you know, there's always some kind of wind. It's kind of gusty up there. Okay, at about 30,000 feet above sea level. So with the influence of the wind speed and the direction of the wind, the travel of the plane, it's going to be not exactly as the plane or the pilot designed to. So when you become a pilot, you need to take the wind speed and the direction into account. Okay, as a very simple example, if you travel with the wind, okay, so you can get to your destination faster because you add the speed of the plane and the wind speed together, so you travel faster. Okay, but if you travel against the wind, then you have to take more time to get to the airplane. So if you travel internationally, you will find out that traveling to the east is always faster than traveling to the west, because up there, because of the Earth's rotation, there's always the wind blowing from the west to the east. Okay, so and the other thing about these wind speed or the direction thing is that you have to understand how to interpret the angle. Now, again, the angle for math usually is like, you know, the right hand side is 0. You have quadrants 1, 2, 3, 4. But that's just a math thing. Okay, very pure math thing. But in direction telling, north is 0, and north is always 0, and north is always north. Doesn't matter which direction you travel to. So I don't care you travel to the east or west. When you have to head north, that will be the same north direction after you go left or go to the east or west. So that's the thing. Okay, so we will need to we'll draw this first vector. That's the airspeed. It will be 177 degrees. So 177 degrees. And that will be 500 miles per hour. And just out of curiosity, can you tell this little tiny angle? Okay, this tiny angle is 3 degrees. Okay, because 180 minus 177, it's 3 degrees. Is it useful? Oh no, but it's something we can tell easily. There is a 70-mile-per-hour wind with a direction of 40. Okay, now, so because it's going to work on the plane, so we have to connect the vectors together from head to tail. 40 degrees. Okay, now north is 0. Remember, north is 0. So if I draw a cross here, right here. Okay, this is the current plane location. And then we say, all right, 40 degrees. Yes, 40 degrees for 70 miles per hour. So let's say something like this. Okay, so we're not going to draw everything exactly to scale, but we need to make an effort to make it somewhat to scale. Okay, so this is 40 degrees. Okay, and this is 70 miles per hour. So we would like to know the ground speed, which is the resultant. Okay, so this purple line right here, that is the actual plane's direction. And that is the speed that we can calculate, which seems like to be shorter than 500 based on the diagram. That would be the actual speed, okay, after taking the speed of the plane and the wind speed both into account. Okay, so we can go ahead and find out the speed of the plane right here. X miles per hour. Wait, hold on. We need something more. We need this angle. So we know it is 40 degrees for the right component of the angle, but what about the left? This little thing right here. What is this? Okay. Now, if you just stare at this, it's going to be difficult to see it. But if you look at the big picture, okay, we were curious about this angle, right? This was 3 degrees. And this is also 3 degrees because they are alternate interior angles. Now, there was a student making a comment a couple of days ago saying that do we always assume to use alternate interior angles? I'm going to make 2 comments based on this question. The first thing is that the reason why this particular student is asking this question is likely that the student is trying to memorize what to do without looking at the situation. Okay, I cannot guarantee you whether there will be a situation where you need to use the alternate interior angles, but that's just one of the tools that you're ready to use. Okay, so do not memorize. Okay? Do not memorize. Okay, about what you need to use, what you must use. Okay, I mean there's some likelihood, but we can expect that we could use, but we don't say we always use it. Okay, and also make sure that you know these former geometry stuff. Okay, so altogether right here, that's 43 degrees. Okay, so to find out x, simply do the big square root, and then you have 500 square plus 70 square, square minus 2 times 500 times 70 times cosine of 43 degrees. So, well, let me go ahead and calculate it. Oops. So 500 square plus 70 square minus 2 times 500 times 70 times cosine of 43 degrees. And I think I need to make sure that it's in degrees. Okay. So now I'm going to press enter. So that's a nice number right there. And then do the square root. So raise to the 1/2 power. So 451.337. Okay, 451.337 miles per hour, which is what we expected, because you can look at the diagram, it seems like shorter than 500. So it is shorter than 500. So a good diagram would allow us to make some good conclusion before we actually get the exact answer. So that's the speed, which is very good. Now, what about the course? Okay, when we say the course, we are saying that what is this direction? Okay, this new direction. Now, for the students who are struggling to answer this question, I want you to understand something at a very fundamental level. Okay, at a very basic level, is that at this point you should know a couple of tools. We have just used the law of cosine, which is the one on the right here. Okay, you should also know the law of sines. And with these tools that we have recently learned, you should be able to find out all the details about this triangle, this obtuse triangle right here. Okay, you should be, okay? Meaning that you should be able to find all the sides, which we do. Okay, we just did actually. We find out the missing side, the purple side. And you should be able to find out all the angles, all the angles, okay? So meaning that you should be able to find out this little tiny angle right here. You should be able to find out this angle right here. Do we have to find out both? No. Then which one we're going to find out? Well, this one. This one, the one that's still highlighted in green, because if we know that angle, which I'm going to label it as delta prime, then I can actually find out the direction. Now, we're going to do the calculation in a moment, but let's just say this delta prime, it's, let's say 5 degrees. How about that? 5 degrees. Okay. Would you be able to tell the new direction? Again, north is 0. Okay. North is 0. So with the purple line pointing to the southeast direction, you should expect that the angle is somewhere around 100 degrees, 100 something degrees. Okay. Like if you are not giving an angle that's 100 something degrees, that's likely to be wrong. Right? Again, good diagram leads you to good conclusions. So if it's 5 degrees for that particular angle, okay, 5 degrees over here, then what's the new bearing? What's the course of the airplane? We'll say, oh yeah, it's just, it was the black line, it's 177 degrees. So you go back 5 degrees. So common sense would tell you that it's what? 172. 172. Okay. So I want you to know how to think hypothetically, okay? And now we say, all right, it's now 5 degrees, so let's go ahead and find out the actual angle. We say, oh, sine theta prime, it's over 70 miles per hour. And then sine of 43 degrees is due 451.337, okay? So with all these information, we can find out the sine theta. Okay, so sine 43. So sine of 43 degrees divided by 451.337, and then times 70. So this would be the sine theta prime. Okay, this is the sine theta prime. Not the theta prime yet. This is the sine theta prime. So in order to find out the theta itself, we need to find out the inverse sine of this number, which is 6.07 degrees. Okay, 6.07 degrees, 6.07 degrees. 07 what? 072. Okay. Okay, so you round up 6.072 degrees. So the actual theta, the actual course, will be 177 minus 6.072 degrees, which is 160, no, it's 170.928 degrees. 170.928 degrees. Okay. Now, the reason why I had a hypothetical scenario to set the delta prime, the theta prime to be 5 degrees, because some students say when they see the ugly numbers like 6.072, so they got more stressed and worried about the answer. So to give you a nice number to work with, that will allow you to think of the concept a lot easier. And just to recap, that the course of the airplane is southeast. Okay, the plane is flying southeast, so you know the direction is gonna be 100 something. Okay, if you draw a good diagram, given that happened. Okay, so please draw a good diagram. Ground speed is the resultant, course is the resultant direction. So make sure that you know the law of sines and the law of cosines to help you find out all the details of this triangle. Okay, label well, draw the vectors somewhat to scale so that you have a good way to tell what it's going to be like for the ground speed and the course. Okay.